In this video, we are going to talk about piecewise function and continuity, and we are going to use the limits. So first of all, let's take a look at the 12 basic functions which you have in your packet. Which of the 12 basic function has the following piecewise definition over separate intervals of its domain? So this is a kind of a warm-up as two pieces. We have x is greater than or equal to 0 and x is less than 0. Let's try to sketch the graph of this piecewise function. If x is greater than or equal to 0, that means on the right side, the slope is of x. X is less than 0, that means on the left side, the slope is negative x. And this is a very, very popular function, which we can say f of x is absolute x. As you can see that absolute x, you can break it into two pieces. One piece on x is greater than or equal to 0, it's a positive x. And when x is less than 0, it's a negative x. And two pieces together becomes absolute value x. Absolute value x functions can be broken into two different pieces. So these are two different pieces. Together, it's absolute x. Now let's take a look at a little bit more complex example. So the direction says following piecewise function, identify the type and point of discontinuity, if any. We will have to use the limit notations to justify, and if it needed, we can use the graph. So let's talk about this piecewise function. The pieces are occurring at -1. That means at x equal to -1, there are two different pieces. So I'm just looking at here. This is my part x equal to -1. This is my boundary. It helps you to split the function. On this side is 2x plus 3, and on this side is -3x plus 1. So how do we use the limit? So let's talk about x equal to -1, and the function is continuous it's defined at -1. So if I substitute -1 here, what value do we get? -2 plus 3 is equal to 1. So from this side, my function value is a 1 and the slope is a 2. I don't need to sketch the graph, but I'm sketching a little piece. On the left side is -3x plus 1. Now, it's not including, but what this means is getting closer and closer and closer. So I'm going to substitute the same -1 value to see what's happening. -3 times -1 is a positive 3 plus 1 is a 4. So from the left side, you are coming at the 4 and the slope is negative. So that's the open circle because it's not including, and the slope is a 3. This is the piecewise function. Now we are interested into the limit notation and checking type of discontinuity. So I'm going to use the limit notation. Limit x approaches -1 from the left. -1 from the left. F of x, what's that? Number is a 4. I'm using this number left. -3 times -1 plus 1. Limit x approaches -1 from the right. I'm coming from the right side, that means this one, and that number is a 1. So clearly, this limit does not exist because they both are different numbers, and we can say that there is a f of x has jump discontinuity type, and where discontinuity at x equal to -1. Why? Reasoning is here. That from the left you are coming at the 4, from the right you are coming at 1. There is a jump discontinuity. Now, if you say what is f of -1, f of -1 is here, and that is a answer is a 1. So know that the limit is different than the function value. Let's take a look at another example here. PCs are occurring at x equal to 0. Now notice that function is not defined at x equal to 0. So we know that f of 0 is not defined. Now let's try not to use the graph, and we can use the function straight here. Limit x approaches 0 from the left. It's very important that you know which function to use from the left and right. 0 from the left. 0 from the left, that means on the left side. And if you want, you can say this is your boundary. X is less than 0, so this is negative 3x minus 1, and this is a square root x, and this is x equal to 0. So the purpose of this space is to know from the left and right. So from the left is a 3x minus 1. If you substitute 0, so 3 times 0 minus 1 is negative 1. And if you substitute 0, here is square root of 0 is a 0. Clearly, these two numbers are not same, so that's why you can say limit x approaches 0, f of x does not exist, and f of x has jump discontinuity. Just a coincidence that we got the same at x equal to 0. If you are interested to sketch the graph, yes, you can see that the both are open circle. This is open circle, and the graph is this, and that is also open circle, and the slope is a 3, 3, 1. So that is the graph. The graph looks like. Let's take a look at some more examples on the other side. It's a different way to do them. Okay, so here is slightly different approach. Solve for a and b such that function is continuous. You want to make a continuous function. So first of all, you have to make sure the function is defined. So what is f of 1? F of 1 is 1 plus 1, 2. Now let's talk about the limit. Limit x approaches 1 from the left. What would be this number? And limit x approaches 1 from the right. What would be this number? To make a continuous function, you have to come at the same, both sides you have to be together, then only you can put all of them together and make a continuous function. So 1 from the left is this one, the top one. So 1 plus 1 is a 2, equal to 1 from the right is a, we don't know a, x is a 1. So this is 2 is equal to a plus 3, a is equal to negative 1. Now here there is only one unknown a. So what this means is when a equal to negative 1, this function will be continuous at x equal to 1 because the function value is the same as those numbers. You can check your answer. If you put it negative here, and you can see that they all will be continuous. X equal to 1, 1 plus 1, 2, negative 1 plus 3 is a 2, and they are all same number. That means function is continuous. Let's take a look at another example. Determine whether function is continuous at x value. So you are checking whether function is continuous or not. And we are looking at what's happening at x equal to 2. So first of all, let's check what is f of 2. F of 2 is here. Function is defined. So negative 2 times 2 is negative 4. Okay, so now we have to check whether the limit value is also negative 4 or not. So let's check from the limit. X approaches 2 from the left and limit x approaches 2 from the right. Okay, so 2 from the left. Again, if you want, you can draw the picture. X equal to 2 here. The left side is a negative 2x. The right side is a x squared minus 4x plus 1. When x is a 2, we know the y value is negative 4. You have to check whether all those values are also the same. So 2 from the left. Negative 2 times 2 is negative 4. 2 from the right. So let's substitute. 2 squared minus 4 times 2 plus 1, which is 4 minus 8 plus 1, which is 5 minus 8 is negative 3. So understand that this side you are at negative 4, the right side you are coming at negative 3. They are not same. So you can say that here, how do we justify? This is all part of the justification function value, limit from the left, limit from the right. And you can say that function f of x is not continuous. X equal to 2 because limit x approaches 2 does not exist. Or you can say there is a jump discontinuity at x equal to 2. That's why function is not continuous. Now it says use limit to justify. That means you must have this limit statement, this 2. Okay, so one more example here. Find the constant a such that function is continuous. Now these are typical questions, very simple, straightforward. You know that the function is continuous. F of 2 is 8. Limit from the left. This is the easiest kind because you put them together. Both sides substitute 2 and put them equal to each other. So 8 is equal to 4a. A is 8 over 4 is equal to 2. Find the constant a such that function is continuous. Put them both side, left and right has to be the same as the function value.